Hey, Professor.
Hi, students. Have you come up with an idea for your statistics project yet?
Oh yeah, we've got a killer idea. Wait till you hear this. Alright, so we're going to test the correlation between money spent on ice cream per year and the number of people killed per year per person.
Okay, that's very interesting.
Right?
How did you get your data?
Okay, so this is also great. We just came back from the local prison and asked the inmates how much money they spent on ice cream in the past year and the number of people they killed.
Well, that's wonderful. I look forward to seeing your data.
Thank you, Professor. This is gonna be so fun. All right, Zach. I just don't know what we're gonna use for our variables. You got an idea?
It's all right. So what I think we're going to do is we're going to use dollars spent on ice cream per year as the x variable, which is the independent variable. And as the y variable, the dependent variable, that's going to be people they killed per year. I think we got a great idea going.
Dude, that's so neat. I'm so excited to do this. All right, let's get plotting. Ready?
Woohoo! Wow, Caleb, this is looking pretty promising.
Yeah, man, that graph is awesome. Couldn't be any better.
And all this talk about ice cream is making me a little hungry. And
Yeah, I get it.
I did just get my tax return in. I'm going to head out. I'll be back.
All right, I'll catch you later, man.
Hello, Caleb.
Oh, hi, Professor.
How did your data analysis go?
Oh, it's going great. We got all of this data, and I just don't know what it means. I don't know what I'm doing. I need some help.
Okay, Caleb. This slope of your line is positive. That means you have a positive correlation. If the slope of your line were negative, that means you would have a negative correlation.
Oh, wow.
But here, because it's positive, that means that we have a direct correlation between ice cream sales and murder rates.
Really?
And now you need to hit the Excel.
All right. All right, Professor, after sleeping on Excel for several hours on a Saturday night, I finally got my hypothesized model and my estimated model.
All right, Caleb, tell me about them.
All right, so in the hypothesized model, alpha just means the y-intercept, beta is the slope of the calculated regression line, and where you're going to use it to calculate probably how many people are killed based on the amount of ice cream sales, and epsilon just means that it's the error in residuals. All right, so after we have our hypothesized model, we got our estimated model, the real calculated equation for our regression line. So given a certain amount of ice cream sales, we can predict probably how many people this guy who bought that much ice cream is going to kill.
Wow, I just spent $300 on ice cream.
Zach, do you know what this means? If I plug in $300, the amount of money you spent on ice cream, that means you're gonna kill 99 people in the future.
Well, I do have 99 problems.
Stop. You guys are morons, and you should pay attention in class. All right, now, your R-squared value is reasonably close to 1, and that means you have a strong positive correlation. However, that does not mean that Zach's a murderer, because this is extrapolation. You only measured up to $100 in ice cream sales, but Zach spent $300. That's not included in this graph, so we don't know. All right, and this is our residual plot. Because it doesn't show a clear pattern, that means that our original graph is a good fit. However, it is only valid for the prison population near the Ben & Jerry's factory, not for the general population at large.
Wow, we learned a lot, Zach.
Yeah, this was really helpful.
I am so glad to know that you're not a killer. Professor, thanks for all of your help.
So you might have realized that we missed one small minor detail, the hypotheses. So our null hypothesis is that the money spent on ice cream does not correlate with the amount of people killed. Now our alternative hypothesis says that the money spent on ice cream does correlate with the amount of people killed. So we reject our null hypothesis and support our alternative hypothesis. 98 to go.